Preterm birth is a growing global human healthcare crisis involving more than 1 in every 10 pregnancies and is the leading cause of infant death and morbidity within the first month of life. Each day, nearly 3,000 babies die from complications resulting from preterm birth. The latest scientific research and discovery in the field of human reproduction brings to light the biomechanical and electromechanical functions of the uterus and uterine cervix, which are stimulated by bearing forces acting upon the tissues of those structures, such as to accelerate the birthing and effacement and dilation processes. Specifically, as the uterus ripens, increasing forces bearing upon the tissues of the uterus and uterine cervix stimulate a biomechanical-based occurrence that is now recognized to excite the complex biophysical and biochemical interactions of electromechanophysiology, which stimulate hormone and enzyme production, triggering softening of tissues, including those of the uterine cervix, in preparation for birth. It is further recognized that force-induced stretch activation of the uterine and cervical tissues alters the electromechanophysiology, such as to increase cervical reactivity and excitement of the effacement and dilation process, a complex cascade of events involving membrane depolarization, increased intercellular calcium activity, ionic currents, and the electromechanical performance of myometrial tissue. This is a primary reason that multiple fetus pregnancies, including those involving cervical incompetence, are so often at high risk for premature birth, as the increased bearing force imposed by the additional fetuses acts to further excite the stretch reaction-induced effacement and dilation process. It has been concluded that these newly understood uterine and cervical tissue features and mechanical functions evolve in distinct stages excited by mechanical loading signals, which cause premature remodeling, shortening, and dilation of the cervix, which is the final common pathway for many etiologies of spontaneous preterm birth. Therefore, in prevention of preterm birth, CSD serves to support the uterine and cervical tissues to lessen the stretch reaction mechanism that excites accelerated birth. Viatech MD's patented cervical stabilization device, known as CSD, is the first and only device-based and medication-free treatment specifically designed to address reduction of bearing forces acting upon the uterine and cervical tissues to slow the birthing and effacement and dilation processes in prevention of preterm birth. With the CSD inflated and in place, stretch reaction mechanisms are relaxed, resulting in decreased hormone and enzyme activity, thereby slowing the birthing and effacement and dilation processes. By utilizing CSD to slow and control the effacement and dilation process, full-term and natural birthing experiences will replace often tragic rescue and emergency treatments involving risky and unproven cerclage and pharmaceutical therapy that do not assure full-term outcomes and often demand cesarean section deliveries.